Okay, in 8.1, the first 4 problems are going to be asking you questions on the lead behavior. Okay, the problems will look like this. It'll say, select one of the 4 sketches that describes the end behavior of the graph of the given function. The end behavior is talking about what the 2 ends of the graph are doing. Are they both going up? Are they both going down? Or is one up going up and one end going down? So the way that you're going to look at that is you look at the terms, however many there are, and you find the highest exponent, which in this case is a 3. That, first of all, is going to tell you whether you have the end behaviors are both going up or both going down. If your leading exponent, which is the highest exponent, is odd, we're going to go by this chart. If your leading exponent is odd, that means one end will be going down and one end will be going up. So, in other words, on this first one, it's either going to be B or D, because you're always, if your leading exponent is odd, you're going to have one end going up and one end going down. You will not have, the ends will not be going in the same direction. When they go in the same direction, that is because the leading exponent is even. So now we have to decide, is the graph going from up to down like that, or traveling up, going from down to up like this? And that's when you say, okay, so we've narrowed it down. Since it's odd, it's going to be one of these, one going up, one going down. So then we look at the term. If it is positive, like this one, since there's not a negative in front of it, it's going to be positive. That means your graph is going to be starting from the down position and traveling upwards like this direction, which means it starts down and travels up, which means this one would be D. So again, looking at this chart, the leading exponent, if it is even, that means your ends are going to be going in the same direction, either both up or both down. Then, if the leading exponent is positive, the leading term is positive with an even exponent, they'll both be going up. If it's negative, they'll both be going down. So, if the leading term's exponent is odd, it'll be one of these, which means they don't go in the same direction. One's down and one's up. If it's odd with a positive sign, it'll travel up like this one. Or if it's odd with a negative sign in front of it, it'll go down like this one. So using that end behavior chart, let's look at number 2. So here, make sure that your exponents are in the right order. So here is my leading term. It has the highest exponent. So first of all, its exponent is even. And what did even exponents tell us? Even tells us your ends are going to be going in the same direction. So that means it is not A or C. They're both going to be going in the same direction. Now, to determine whether they're going down or up, like this, you look at the sign. Since this one is negative, remember the negative in front of the function is telling you what flips the function upside down. That's what makes it go down like this. So even exponent with a negative in front means both ends would be going down, which means this one would be B. Number 3. Now, the leading exponent does not just mean the first one, it means the highest exponent. So this is actually your leading term of this function. You want to be looking at the highest exponent, which means it is odd and positive. So let's see what that means. Odd and positive means different directions, starting down, going up. So again, odd, sorry I'm going back and forth, means it's not this one or this one, since those ends are going in the same direction. It's going to be one of these. And since it's positive, it starts down and travels up, like this C. All right, the last one talking about these kind of problems. So again, we're looking for the highest exponent. The term with the highest exponent is going to be our leading term. So our leading term will be that one. So its exponent is even, which means the ends of the graphs are going to be doing the same thing. Not one up, one down, but both doing the same thing. So neither one of those. So it's either this one or this one. This is a positive and that one's negative since it's upside down. So since this is a positive, it would be A. So even made them both go up, positive, or made them be the same, and positive made them both be up. Now, on number 5, it says use substitution to determine whether 2 is a 0 of the following function. So all I'm going to do in this function is replace those x's with that 2 and then see if it gives me 0. So all I'm going to do is replace, again, these x's with 2's. So I will have, open parenthesis, 2. Now to raise it to the third power, I will simply, this will makes it go up into the exponent, this little up arrow, and then push whatever number you want the exponent to be. Now, to get out of the exponent, you'll need to push, watch what happens when I push this right arrow. It gets me back out of the exponent. So there's my 2 to the third. Now I need net minus 9, open parentheses, 2 squared plus 12, open parentheses, 2 plus 4, and then hit enter. And it does give me a 0. If it gave you anything else, the answer would be no. But since it gave you a 0, the answer would be yes. Now, starting with number 6. When it gives you a function like this and asks you to find the zeros, what it's wanting you to do, if what is in here is not in factored form, you'll need to factor it first. This exponent is talking about the multiplicity. Okay, so it doesn't have anything to do with what's, it's just going to tell me the multiplicity. And we'll talk about the multiplicity here in a little bit. So this right here, I need to factor what is inside these parentheses, which is x squared minus 4. Okay, if you'll recall from factoring, if you took an algebra course before this, if you're factoring, this is a difference of perfect squares with x and x giving you x squared. To get the negative 4, you will need a plus 2 and a minus 2 to get negative 4. So there's the factoring of it. Once you do the factoring, you'll set your factors equal to 0. And solve them for the x. So here, subtract 2's from both sides, so x equals negative 2. And here, add 2 to both sides to get x equals positive 2. Now, remember the quad program that we talked about a couple of sections ago? Any time you're solving and trying to find zeros and your problem is something squared, you can use that quad program. Remember, under program, that first one was quad on mine. Now, a is the number in front of x squared, so it would be 1. Here's where you'd have to be careful. Remember, b is the number in front of x. Here, we don't have an x, which means your b is actually 0. C is the constant, which means the number at the end that doesn't have a letter associated with it. So in this C is negative 4. So look what it gave you. If you are trying to solve anything squared, you can use the quad program because look what it did. It knocked out all this work and just gave me that 2 and negative 2 that I got. So 2 and negative 2 are the zeros. Now, the multiplicity, so positive and negative 2 are your zeros. This exponent out here is talking about the multiplicity of those zeros, which is 5. So positive and negative 2, each with a multiplicity of 5. Now, on these next problems, these are actually easier. The difference between this one and these is that inside these parentheses, I had factoring to do. Look at these. None of these have any factoring to do on the inside of the parentheses. So your zeros come from these 3 factors. The first one is just an x. Remember, that's the multiplicity. It doesn't have to do with, so if I set that factor equal to 0, here's this one, set it equal to 0, and then the last one is x plus 9, set it equal to 0. So those are your 3 factors that you're looking at here. If you solve them each for x, that gives you the 0. So your zeros come from the factors, just like they did here. Except I had an extra step here because before I could get to the zeros, I had to do the factoring and solve them. Here, there's no factoring to do. Everything is already just x. So this one's actually already even solved. So one of the zeros is 0. This one I need to add 1 to both sides. So that 0 is 1. And here I have to subtract 9 from both sides. So this 0 is negative 9. So your 3 zeros are 0, 1, and negative 9. So make sure when because it wants them very specifically here, your smallest 0, so which one of these is the smallest number? It is negative 9. So now, when you come back, look at the factor where that came from. It came from this factor here. What is its multiplicity? Or in other words, what is the exponent outside of that factor? Since you don't see it, it's like an understood 1 there. So its multiplicity is 1. All right, so there's the smallest one. So 0 is the middle one. So go back to the factor that it came from. Here's the factor that it came from. What is its multiplicity? This 7. And then the highest or the largest 0 is the 1. And where did it come from? It came from this factor right here. So what is its multiplicity? This 2. All right, number 8. Again, there's no factoring to be done. Let's look at what the 0, 2 has a multiplicity of what? So here's where the 2, 0 would come from, right? Because if you set this factor equal to 0 and solved it, you would get x equals 2. So the 2, 0, comes from this factor. So what is its multiplicity? This 3. So which one is the 0 that has multiplicity of 4? So here's the one that has multiplicity of 4. So it's coming from this factor, the x plus 5. So when you set it equal to 0 and subtract the 5 from both sides, the 0 that has multiplicity of 4 would be negative 5. Now, I've done this one and I've done this one. So the remaining 0 comes from this x at the end. So if I set this x equal to 0, it's actually already solved. There's nothing to solve to get that x by itself. So the remaining 0 is actually 0. And what is its multiplicity? That outside exponent, which is a 2. Okay, now on these next 2, you're just going to have to hang with me. So find the zeros of the function and their multiplicities. If you do not remember factoring 4-term polynomials by grouping. So just like this last problem or not the last problem, but the one over here, this one right here where we had factoring to do because it wasn't in factored form yet. It wasn't in factored form yet. I had to do the factoring. I'm going to have to do the factoring here also. So let's look at what this entails. So I have x to the third minus 8x squared minus x plus 8. So we're going to factor this 4-term polynomial by grouping. So there's 4 terms, so we're going to put them in groups of 2. So just group the first 2 and the second 2 together. Now, once you do that, you'll look at your first group, just these 2 terms, and pull out the greatest common factor. Well, the only thing they have in common is x's. They actually have x squared in common. So I can pull out an x squared. Now, once I pull out the x squared, if I take x squared out of this term, I'll just have an x left. Minus, if I take the x squared out of this term, I just have 8. So now, in this next group, I need to pull something out. It's going to be part of my answer at the end. You want what's left over in this group coming out of here to match this. So I need it to be positive x minus 8, which is exactly opposite of what I have. I need positive x minus 8. So in order for that to happen, I need to pull out a minus 1. Because if you pull out a minus 1 and divide those both by that negative 1, it'll turn this x into a positive. Then I have positive 8 over negative 1, which makes it minus 8. So now, once you do this, and I told you just got to hang with me, these x minus 8s are now kind of like the greatest common factor of this polynomial. So I'm actually going to pull out that x minus 8, put in parentheses what is left. So if I take out the x minus 8s from both of these, look what's left. You have the x squared here and the minus 1 there. So you have x squared minus 1 left. Now, this is completely factored. However, this is not. I have x squared minus 1. So since I still have an x squared on the inside, I have to factor this again. This is actually a difference of squares. You can use x and x to get the x squared. To get negative 1, you'll need to have a positive 1 times a negative 1. So now that's completely factored. Let's just drop down this x minus 8. So here's all my 3 factors. So these are the factors that you were going to set equal to 0 to find the zeros of the function. So I'll have x minus 8 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Solve them for x, so add 8s here. So that x equals 8. Here, solving for x, so I'll subtract the 1. So now I have x equals negative 1. And here, add the 1. So that answer is x equals positive 1. So your 3 zeros are 8, negative 1, and positive 1. So the zeros of the function are x equals 8, negative 1, and positive 1. Now, each 0 has a multiplicity of what? So to find the multiplicity, go back to the factorization where they are all completely factored, which is right here. They all have a multiplicity of 1, since there's not any exponents other than that understood 1 out behind all of them. So each of these zeros that come from these factors has a multiplicity of 1. Now, number 10, I'm going to work on a sheet of paper. It's the same kind of problem. So let's see, I've got 5x to the third minus x squared minus 180x plus 36. So I'm doing the same thing I did on the last problem. So since it's 4 terms, again, I'm going to put them in groups of 2 and factor them by grouping. So looking at my first group, I see that they have an x squared in common again. So I'll pull out the x squared. So if I take an x squared out of this first term, I still have a 5x left. Minus, if I pull out x squared from this, and when I'm talking about pulling out, remember I'm talking about dividing that by x squared, which is what I did to both of these. So all I'm left with here is a 1, right? Because x squared over itself is 1. Now remember, just like the last problem, I want what is left in this second group to actually match what is in this group. That's what's leading me to thinking, okay, if this last number is going to be a 1, like I need it to be, that means I'm probably going to need to pull 36 out of there. So let's see if 180 180 divides by 36, to see if I can pull a 36 out of there. Well, look, it does. So let's think about this. So I'm going to pull a 36 out, since 36 goes into both of those. Now remember, what kind of 5x are you going to need to be right here? If it's going to match this one, it needs to be a positive 5x. This is going to leave me with a negative answer, right? Because I've got a negative over a positive. So that's what's telling me I actually need to pull out negative 36. Because negative 180 divided by negative 36 is what's going to actually give me positive 5x. And then look, positive 36 over negative 36 is negative 1. So if you'll notice, these two match. They're the same. So that's one of the factors. The other factor is what's left after you take out the 5x minus 1 from both of those, which you'll see will just be the x squared and then that minus 36. So once again, just like the last problem, this is a difference of perfect squares left in this second parentheses that I'll need to factor some more. So x and x for x squared. To get negative 36, I'll need a positive 6 times a negative 6. And then just drop down this 5x minus 1. So there's your factors. Remember, where do zeros come from? Your zeros come from setting your factors equal to 0 and solving them for x. So let's see, this first factor, when I set it equal to 0 and solve it for x, I would need to add 1. So 5x equals 1, divide by 5. So that x, or that 0, is 1/5. Here, subtract the 6. So x equals negative 6. And here, add the 6. So x also equals positive 6. So your zeros are negative 6, positive 6, and positive 1/5. So 1/5, negative 6, and positive 6. And again, they all have multiplicity. Again, when you're talking about the multiplicity, you're looking at the exponents, at your final factoring, which is right here, and they all, again, have exponents of 1. Which means multiplicities of 1. Now, what do the multiplicities tell me? Let's look at these notes that I have here. If the exponent of the factor is even, then the graph is tangent to the x-axis at that 0. What that means is at the x-axis, because what a 0 tells you is that the graph is going to either touch or cross the x-axis at whatever that number is. So the 0, if the factor has an even exponent, then that just means that it's going to just touch the x-axis at that point and then go back the other way. If the exponent of the factor is odd, that means that the graph crosses the x-axis at that 0, which means it would cross it instead of just being tangent or touching it and going the other way. So again, an even exponent makes the graph be tangent at that 0. An odd exponent makes the graph actually cross through the x-axis at that 0. So let's look at the last two problems. Yes, the last two problems. Number 11 says, if p of x equals x minus 5 squared times x plus 6 to the 9th, then the graph of the polynomial function crosses the x-axis at 5, 0. So let's think about what that is. So where did this, so the 0 is 5. So let's come back here. Where did that 0 come from? It came from this factor, right? Because if this is minus 5, if I set it equal to 0, it would give me that positive 5. So it came from this factor. What is this factor's exponent? It's a 2, which means it's even, which means it is not crossing. It needs to, because what do even exponents tell you? The even exponents tell you that they are tangent to the x-axis. So this statement is going to be false. So not true, not true. It's going to be false because x minus 5 is a factor and the exponent 2 is even. So the exponent is even. Thus, the graph is tangent at 5, 0 instead of crossing. Okay, so that's why it is C. Because the exponent of that factor is even, then the graph is tangent to the x-axis, not crossing the x-axis at that point. All right, number 12, same thing. So here's one factor, x minus 9 to the 5th. The other factor is x plus 1 to the 10th. The graph of the polynomial is tangent to the x-axis at -1, 0. So let's go back and see where this 0 came from. It's -1, which means it came from this factor. So there's the factor that it came from. Its exponent is even, which means that is true. It is tangent, right? Only odd exponents tell me to cross. Even exponents tell me to be tangent. So this statement is true. Okay, so it's not false. So it's not the last two. It is true because the exponent 10 is even. 10 is not odd, so it's not that one. It is true because the exponent 10 is even.